Hello, are you ready to simplify expressions with fractional exponents? If yes, let's go. To simplify expressions with fractional exponents, we need to gather our understanding on the laws of exponents to be applied here. And then definitely later, we're going to apply another technique to simplify it further. Let's start with number one. Number one here is a combination of two different exponentiations with the same base, 6 and 6. This is under multiplication since there are no other operations separating them. And if that is the case, we are going to use here the multiplication law of exponents. That if we have the same base, we just copy it. Let me write it a little bit lower here. Copy the base and add the exponents. So you have negative 1/3 plus 5, 6. Take note that our exponents are actually in fraction forms. So to add fractions, we need to make sure that they are similar fractions. If that is the case, we're going to look for the LCD of the numerator here. So still copy the base. The LCD is 6, and the other is also 6. 6 divided by 3 is 2, times negative 1 is negative 2. And then 6 divided by 6 is 1, times 5, you have here 5, which will then be equivalent to 6 to the power of negative 2 plus 5 over 6, or 6 to the power of 3 sixths. That is the result of the exponent. Now we can still simplify the exponent as 1/2 because that is its lowest term. After this, there is another law for if we are going to have multiplication law of exponents, division law of exponents, power law, law of zero exponent, law of negative exponents. We have the sixth form of laws of exponents, which is also called as the law of fractional exponent, wherein from this expression, we could transform this into an expression with a root symbol, or the other term for that is a radical expression. It is a radical expression where the form or the base will become a value inside the root symbol. The numerator of the fractional exponent will become the exponent of that value of 6, and the denominator will become the value here. And we do have names for this, by the way. The 6, or the base of the base of the expression with fractional exponent, will become your radicand. The numerator of the fractional exponent will become the exponent of the radicand, and then the denominator will become the index. This is actually just equivalent to, but it is when we have 2, that's just the same as not writing. That means square root, and 6 to the power of 1 is just 6. So the answer for number 1, after applying the laws of exponents here, to simplify the remaining expression with a fractional exponent, we could transform it to a radical expression with this process. Again, the base will become the radicand. The numerator of the fractional exponent will become the exponent of the radicand, and the denominator of the fractional exponent is the index, which will then be equivalent to this. With this information, let us try to continue until items 2, 3, and 4. But then again, we will use first the important laws of exponents. Here, we do have the same basis of 16. So you have copy the 16. But instead of adding the exponents, since they are under the operation of division, let's subtract the exponents. So you have here 3, sorry, this is 3 halves minus 5 fourths. Okay, and LCD is 4. So you have here 4, then minus another 4 here. So 4 divided by 2 is 2, times 3 You have here 6. And here it's still 5 because the denominator did not change. And then let me write it here at the bottom. So you have here 16 to the power of 1/4. And by transforming it to a radical expression, this will become, again, 16 will become the radicand. You'll have the root symbol. The numerator of the fractional exponent will become the exponent of the radicand, and the denominator will become the index here. This means we are asking for the fourth root of 16. And 16 is actually a perfect fourth number because 16 is the result when 2 is multiplied by itself 4 times. 2 times 2, 4 times 2, 8 times 6 times 2, another 2 is 16. This is why the fourth root of 16 is actually 2. More explanation to this will be covered on the next chapter, which is on radical expressions. As of the moment, it's important for us to apply the laws of exponents, transform the expression with a fractional exponent to a radical expression, and then, if possible, we could simplify it, simplify the radicand by familiarizing the perfect square and perfect cube, and even the perfect fourth of a number. Let's proceed to number 3. Here, we will be using the power law. The power law allows us to distribute this to the expression here and there. But it will become like this. You have 8 to the power of negative 2 over 3 raised to 2. I mean, times 2 rather. All over 2 squared. Okay? So if you have this expression, you could just actually say it's 8 to the power of negative 4 thirds. That's 2 times 2, and then it's over 1 here, all over 2 squared. Why is it that I did not express the value of the denominator to become 4 as it is the value for 2 squared? Because we can still simplify this. By simplifying this, it doesn't mean that we can just subtract immediately exponents, etc., etc. Take note that if and we could only use the division law and then the multiplication law if the bases are the same. But 2, 8 here can be expressed as an expression with base 2 because 8 is equal to 2 cubed raised to the power of negative 4 thirds all over 2 squared. Do not touch yet or change yet the denominator. Let's just simply continue. In the numerator, we will use the another power law, 2 to the power of 3 times negative 4 thirds, which will then, again, 3 over 1, or can simply cancel that out. Okay, cancel that out. And you will have here the expression for the denominator still 2 to the power of 2. And then you will have 2 to the power of negative 4 over 2 squared. From here, you could have two options. Number one is when you will apply a division law and you will have 2, since they have the same basis now, negative 4 minus 2, which will yield to 2 to the power of negative 6. And then since the exponent is a negative number, we could apply the law of negative exponent by moving it down, leaving 1. There should be a value in the numerator. 1 could do because this is actually can be written as the expression times 1. So there is always 1 for a numerical coefficient of the numerator, and you will have 2 to the power of 6. And 2 to the power of 6 is actually 2 times 2, which is 4 times 2, 8, 16, 32. You have here 64. So this is actually 1 over 64. This is one of the processes you could do by immediately applying here the division law. But you could also apply here the law of negative exponent by placing or moving down the negative exponent here. And you will have, again, just like this one, a remaining numerical coefficient of 1 over. You will still have 2 squared in the numerator, I rather denominator, but there is additional of 2 to the power of 4. The 2 squared, again, will be retained there because the exponent here is a positive number. And with this, you can apply the multiplication law on the denominator alone. So you'll have 1 over 2 to the power of 2 plus 4, which will yield to 1 over 2 to the power of 6, still 1 over 64. So as you can see, it's a little bit faster right now because we are hoping that you have already mastered the laws of exponents. Just applied now for a fractional exponent. And finally, for number 4, take note that it's 2 and 25 here. We cannot express any of the 2 as base of the other. We cannot express 2 as base 25 nor 25 as base 2. So we cannot use here multiplication law nor division law. What we could only use here is the application of the power law. So this would become 2 to the power of negative 1 half times 2, and then times 25 raised to the power of 1/4 times 2. Let me increase some spaces here for more computation. Okay. Pardon my handwriting. I would like to make it big so that it would be emphasized. And here you will have, again, cancel that out. You have 2 to the power of negative 1 times, if you're going to cancel this out, 2 times 1/4 or 2/4 will become 1/2. So we have 25 raised to 1/2. Then you can move down the 2 to the power of 1 to make the exponent positive. So you have here 2 to the power of 1. And the numerator will become 25 raised to the power of 1/2, which could be transformed to a radical expression wherein 25 will become an radicand. And then the root symbol here, the numerator will become the exponent inside for the radicand, and you have here 2 for the index. The denominator will just become 2 since it's just 2 to the power of 1. The numerator will become square root of 25, which is just 5, and the final result is a fraction 5/2. So again, the process here involves the power law. And since we cannot combine them by using multiplication or division law, we just simply continued in such a way that they could be simplified further. So that negative 1 here exponent, the expression with the negative exponent here was moved down and then squared for this area, and you will get 5/2. So this is where the processes for the laws of exponents are now applied for expressions with fractional exponents. For the next video, still the laws of exponents will be applied for exponential equations. Goodbye, everyone.